Okay, continuing on, we are going to look at solving. So, notice the instructions, solve and check. You have to make sure that you check your answers. So you want to solve it and then check in the original equation. Okay, and we know the steps for solving. The steps for solving, we are going to simplify both sides of the equation. Then we're going to gather all the variables on one side and the constants on the other, and then finally get the x by itself. Okay, so if I have x minus 2 is equal to 18, what's done to the x is we've subtracted 2. To undo that, we have to add 2 to both sides. That becomes 0, and you get x equals 20. But you have to check that. And all you do is plug 20 into the equation. You want to know if 20 minus 2, if that's equal to 18, and you can just know that 20 is equal to, 18 is equal to 18, so it checks. Now, it doesn't matter what side of the equal sign your variable is on. So if I have 12 equals m plus 5, I can get the m by itself, but it's on the right side. It doesn't matter. So since I added 5, I'm going to subtract 5 from both sides, so I get that m is equal to 7. And for my check, I just want to know, is 12 equal to 7 plus 5? 12 is equal to 12, so it checks. If I have negative 3x is equal to negative 24, this is negative 3 times x, so I'm going to divide both sides by negative 3. Anything divided by itself is 1. So I'm left with x is equal to, and negative divided by a negative is a positive, and 24 divided by 3 is 8. My check is very simple. I know on these one steps this seems like a pain, but keep in this habit and it will really help you with like a sign error. Alright, so I want to know if negative 3 times 8 is equal to negative 24. Negative 24 is equal to negative 24, so it checks. If I have negative 2/5 x is equal to 6, then I can multiply both sides by the reciprocal. So this will become negative 5 over 2 times negative 2 over 5x is equal to negative 5 over 2 times 6, and I'll put that as 6 over 1. Okay, so negative times negative gives me 10 over 10, so this reduces to 1, so I'm left with x. All of this reduces to 1. Negative 5 times 6 is negative 30. 2 times 1 is 2. So x is negative 15. So my check on this, I want to know if negative 2 over 5 times negative 15 over 1, is that equal to 6? Well, this becomes 30 divided by 5 is equal to 6, and that is true. All right, if I have a divided by 12 is equal to 1/2, that means I can multiply both sides. Since I divided, that means I'm going to multiply both sides times 12, and since they're fractions, 12 over 1. Anything divided by itself becomes 1. So I have a is equal to 12 divided by 2, which is 6. Okay. Then for my check, I want to know if 6 over 12 is equal to 1 over 2. Well, this simplifies to 1/2 equals 1/2, so it checks. Okay, so if we have more than one step, we have to remember to undo them in order. So what did I do to the 6, and how do I undo it? Well, I multiplied times 6, and then I subtracted 12, so to undo it, I'm going to add 12 and divide by 6. Again, do this in your head. It's not something you must write down. So I'm going to add 12 to both sides. That gives me 0. So I have 6m is equal to 0, which is fine. That's perfectly legitimate. And then I will divide both sides by 6, and I get that m is 0 because 0 divided by anything is 0. For my check, I want to know if 6 times 0 minus 12 is equal to negative 12. Well, that's 0, so I have negative 12 is equal to negative 12, and it checks. Okay. Well, now I have variables on both sides, but both sides are as simplified as they can be. There are no parentheses and there are no terms to combine. So I'm going to start out by getting the variables together. I prefer to move the variables to the left, but you can do it to either side. But I'm going to subtract 3x from both sides. So that gives me 2x plus 3 is equal to negative 5. Next, I have to subtract 3 from both sides. And that gives me 2x is equal to negative 8. And finally, I divide both sides by 2, which gives me that x is equal to negative 4. For my check, I go back to the original equation. I want to know if 5 times negative 4 plus 3, is that equal to 3 times negative 4 minus 5? Okay. Well, this becomes negative 20 plus 3, negative 12 minus 5. This is negative 17. This is negative 17, so it checks. Okay, so I've got parentheses over here, so now I'm going to have to simplify this side by distributing. So this becomes 4x plus 12 is equal to 100. So I'll subtract 12 from both sides. That gives me 4x is equal to 88. When I divide both sides by 4 to get the x by itself, I get x is 22. So for my check, I want to know if 4 times 22 plus 3 is equal to 100. Well, 22 plus 3 is 25 is equal to 100. So it checks. If it doesn't check, you've either done your check wrong or your solution is incorrect, and you need to go back and find out what happened with that. Okay, so I've got variables on both sides. Over here, everything is fine. Here, I'm going to have to distribute. So this becomes 3x minus 5 is equal to 5x minus 2x minus 12. Before I do anything else, I am going to combine my like terms. So that gives me 3x minus 5 is equal to 3x minus 12. I'll subtract 3x from both sides. Well, and it's 0 over here as well, so I have negative 5 is equal to negative 12. This is never true. So it doesn't matter what you put in for x, you can never make this a true statement. So there is no solution. Or you can put a 0 with a slash through it. All right, so most of us don't like dealing with fractions, but we can get rid of the fractions immediately. And so we can multiply the entire equation by the least common denominator, which in this case is 4. So I'll multiply this entire thing times 4. So that gives me 4 over 1 times 1 over 4 times x plus 4 is equal to 4 over 1 times 1/2 x minus 4 over 1 times 3/4. Well, anything divided by itself becomes 1, so on the left-hand side I'm just left with x plus 4. This becomes 4 over 2, which becomes 2x. This is 12 over 4, which becomes 3. Now in this situation, since this one is bigger than this one, if I subtract the x, that means it will be positive and it'll save me a little bit of work. So I'll subtract x from both sides. That tells me that 4 is equal to x minus 3. When I add 3, I get that x is 7. Now I used up all my space, so I'm going to have to do my check really small. All right, so I want to know if 1/4 times 7 plus 4 is equal to 1/2 times 7 minus 3 over 4. Okay, well this is 1/4 times 11, and this is 7/2 minus 3/4. Well, this is, since I put that over 1, is 11 over 4. And I'll get a common denominator here, which is 4. So I'm going to multiply by 2 over 2. So this is 14 over 4 minus 3 over 4. So finally I have 11 over 4 is equal to 11 over 4, and it checks. Oops, my phone rang. Okay. All right. Got rid of that. Well, I thought I did. Okay. So if I want to solve a formula for a letter, that means get the letter by itself. So my goal is, over here, I want to get a y by itself. So the first thing I have to get rid of is the 6x. So that goes away, and I'm left with 5y is equal to negative 6x plus 15. Then I want to divide everything by 5, so I end up with y is equal to negative 6/5 x plus 5. Now, you can also write this as y equals negative 6x plus 15 over 5, or you can write it as 15 minus 6x over 5. And I'll accept either of those. This is what we eventually want to get to because of what we're going to do in Chapter 3. All right, if I have p equals 2l plus 2w and I want to solve for w, That means I need to get the w by itself over here. So I'm going to subtract 2L from both sides. So that gives me P minus 2L is equal to 2W. So now I want to divide everything by 2. So that gives me P over 2 minus L is equal to W. Or you can just write it as P minus 2L over 2 is equal to W. Either way is fine on that one. Okay, if I want to convert to a decimal, okay, remember the Dr. Pepper rule. The Dr. Pepper rule. If I'm going from a decimal to a percent, I move it 2 places to the right. If I'm going from a percent to a decimal, 2 places left. So for a percent to a decimal, I move this 2 places to the left, and I have to put a placeholder in there. So this is 0.07. And I drop the percent sign. Okay, my decimal is right here. I move this 2 places to the left, so this becomes 2.54, and I drop that. If I'm going from a decimal to a percent, I move it 2 places to the right, so this becomes 35.2, and then add this percent sign. 7.2, put my placeholder of a 0, and that becomes 720%. Okay, so let's start solving problems. If I'm dealing with a percent equation, remember the general equation is the percent of the whole is equal to the part. Okay. So you're going to have a percent, you're going to have 2 numbers. This is what I call the of number because the of comes just in front of it, and this is. So what number is 25% of 320? So something times something is something. Well, this is 25% of 320 is what I'm looking for. And you are going to convert percent to your decimal in the equation. So 0.25 times 320 is what we're looking for. And if I multiply this out, I get that x is 80. What is 12% of 600? So something times something equals something. So what is, that's what they want to know. So that's 12% of 600. So this is 0.12 times 600 is equal to x. So x is 72. What percent of 250 is 50? Okay, so I've got something times something equals something. What percent? That's what they want to know. Of 250 is 50. So if I have x times 250 equals 50, to find x, I divide both sides by 250. And I get that x is 0.20. But now I have to write it as a percent. So if I'm going from decimal to percent, I move it over 2 places, and that gives me 20%. Okay, we'll do one more video for the rest of these. They take a little bit of time.